Okay, let's see, guys. Get this set up. All right, we're going to cover Go Michigan State, by the way. All right, talking about arithmetic sequences last week. Arithmetic sequence here: 12, 9, 6, 3, 0. Notice we have a common difference, and we lose a. It's a linear type relationship. We lose 3 every term. Okay. And in this case, we're down 3 every term, but there's a common difference. Today, we're going to go into geometric sequences. We're going to kind of define them recursively, which means we're going to use one or another term to define the. One term might be given or something, but we'll need another term to help define the sequence. Okay, all right. So here I'm going to start off with a sub 1 equals a. So there's kind of defined in the previous term, all right? We have a common ratio, not a common difference, and that's a sub n on the common ratio divided by a sub n minus 1. That means like the 9th term divided by the 8th term, the 10th term by the 9th, the 2nd divided by the 1st. So this is the a sub n and the prior term, okay? You divide those, you get a common ratio, okay? R is your common ratio. So, given that a sub 1 equals a, the nth term will be the common ratio times by the previous term, okay? Or if you want to write it this way, the previous term times the common ratio, either way. So if I want the 10th term, I'll take the common ratio times the 9th term, or the 9th term times the common ratio, okay? So I've got the a sub 1 equals a, the nth term divided by the previous term, the n minus 1 term, gives me the common ratio. The 2nd term divided by the 1st, etc., gives me my common ratio. All right, so to find the nth term recursively, notice we needed to have a term prior to do that, okay? A sub 1 equals a. The nth term equals the common ratio times the n minus 1 term, okay? Take the common ratio times the prior term, you get the next term, okay? All right, let's beat that one down, okay? Here's a sequence alpha, 12, 6, 3, 3s, 3/4, all the way to a sub n, all right? So a sub n equals the ratio times the prior term, okay? A sub n minus 1, okay? So the ratio is, obviously, the nth term divided by the n minus 1 term, okay? The 2nd divided by the 1st, okay? So let's see if this is a geometric sequence. A sub 2 over a sub 1. The 2nd divided by the 1st is 6 over 12 is 1/2. Okay? The 3rd term divided by the 2nd term. A sub 3 over a sub 2 is 3 over 6 is 1/2, etc. This, okay? 3/2 over 3. That would be 3/2 divided by 3. All right, is 3/6. This goes down here, okay? And that's 3/6. So we got 1/2. So that is a geometric sequence. Everything, our common ratio is 1/2. All right? Recursively, a sub n equals r times a to the n minus 1. Okay? There's our recursive sequence. Like if we wanted the 4th term, it'd be r times a to the 3, which would be 1/2 times 3 is 3/2. All right, so I'm really beating a dead horse here on the common ratio, basically defining the next term as the previous term times the common ratio. Okay, that's all we got to be. All right, moving on. There's not a lot to this for what we're going to cover. Is the sequence geometric? 2, 6, 18. Well, let's take a look. Let's find the common ratio, if there is a common ratio. The nth term divided by the n minus 1 term. Okay? The 2nd divided by the 1st. That's 3. Equals what? The 3rd divided by the 2nd, 18 over 6. That's 3. Equals the 4th divided by the 3rd, 50 over 18. That's 3. 162 divided by 54. They all equal 3. That's our common ratio. We have a common ratio of 3. Our first term equals 2. Okay? So, our nth term equals our common ratio times the term prior. 3 times a to the n minus 1. There's our recursive sequence for a sub n. All right. Here's another little thing, just an example. I just want to show that this sequence S sub n equals 2 to the negative n, that is geometric. So remember, 2 to the negative n is the same as 1 over 2 to the positive n. So we just start plugging in numbers here. 1, 2, 3, 4. Notice here's my n. 1, 2, 3, 4. 1 is 1/2. If I plug in 2, 2 squared is 4, 1/4. 2 cubed is 8, so that's 1/8. And I plug in 4 in here, and that's 1 over 2 to the 4th, 1 over 16. So 1/2, 1/4, 1/8, 1/16. Is this geometric? Okay. I take this n divided by the n minus 1, the second divided by the first, 1/4 divided by 1/2. Remember, this will be, ends up being 2/4. Remember how you take 1/2, and I'm going to divide, 1/4. I'm going to multiply by that reciprocal, 2 over 1, and that's ends up being 2/4 or 1/2. Okay, so when you divide by fractions, multiply by the reciprocal. Okay. All right, the third term divided by the second. 1/8 divided by 1/4 is 4/8. That's 1/2. 1/16 over 1/8 is 8/16. That's 1/2. So that is geometric. That checks off. Okay. Okay. The nth term of a geometric sequence will be, it's just like arithmetic. Notice, if I want the third term, I'll multiply 1/2 by 1/2 2 times. If I want the second term, I multiply it by the common ratio 1 time. Like I said, it's for the fourth term, 1, 2, 3. I'll multiply the first term 3 times to get the fourth term. So you're always 1 shy of the term you want, just like arithmetic. So the nth term of a geometric sequence is, the nth term equals a sub 1, my first term. Instead of plus, it's multiplied by the common ratio to the n minus 1. If I want the 10th term, it'll be a sub 1 times the ratio to the 9th. 10 minus 1 is 9. You're always 1 shy of applying that common ratio. If it's the 10th term, you apply the common ratio 9 times, okay? Just like in arithmetic, if you would add or subtract a common difference, 1 less than the term you wanted, okay? Here's an example. 10, 9, 81 over 10, 729 over 100, all the way to a sub n. Let's find the nth term, get the formula. What do we want to get? Yeah, we want to get the nth term. I'm sorry, this is what we're looking at here. We want to find the nth term, okay? So my formula is a sub n equals the first term times the common ratio to the n minus 1. All right, let's first get what? The common ratio. All right? A sub n divided by a sub n minus 1. Okay? All right, common ratio, a sub n over a sub n minus 1. The term divided by the term prior. Okay? So I've got 9 over 10 is 9/10. That's the same thing as 81/10 over 9. 81/10 over 9 is 81 over 900. That's 9/10. Okay, that simplifies. This divides by 9. This divides by 9. 9/10. Okay, so we have a common ratio of 9/10. So remember our formula. I take the first term times the common ratio to n minus 1. Well, the first term is 10 times the common ratio of 9/10 to the n minus 1. Okay, all right. So there's our formula for the nth term, okay? All right, nth term is a sub 1 times r to the n minus 1, all right? So if I want the 9th term, a sub 9 equals 10 times the common ratio of 9/10 to the 9 minus 1, or 10 times 9/10 to the 8. Now remember, this is a fraction, so the more we multiply by a fraction, the more this is going to get smaller. It's like a decay rate, right? This is base rate here. This b is less than, this is an exponential function, basically, and this b is less than 1. So it ends up being this 10 multiplied by 9/10 to the 8th power ends up being 4.304. So it shrinks because this is a fraction, okay? But basically, you just plug in first term times the common ratio to the n minus 1 power, 9 minus 1, all right? All right, the recursive formula, I want to get the first term and get the common ratio, okay? The first term was 10, the common ratio is 9/10. So for my recursive formula, I give the term that's required, a sub 1 equals 10. So a sub n is going to be what? R times a to n minus 1. So here's my recursive formula. 9/10 times a to the n minus 1 is a recursive formula. Okay, that's for, remember, so it's pretty basic. It's not as complicated as the nth term. Basically, I'm looking for a recursive formula. Got a sub 1, all right, is 10. So the nth term equals the common ratio times the term prior, right? Okay, so that's a sub n equals the common ratio 9/10 to the a sub n minus 1. That's pretty simple. That's all we're going to really cover today. We'll do some more with sums on Tuesday as far as doing the summation of a geometric formula. So not a lot to do today, okay? Just basically getting a recursive formula. The ratio times the term prior gets you the nth term. Okay, that's it. Take care, guys.